Hi guys, today's notes are on sketching graphs of polynomials, and in order to do that we're going to do a quick review of the few things that we learned yesterday. So first off, standard form. That is when, I'm so sorry, I'm going to pull this up so I have my reference sheet. Okay, that is when you write your equation written in descending order of exponents, big to small. Let's see. Degree, that's our highest exponent or largest exponent. Leading coefficient is the number in front of the first term, but it has to be in standard form. An end behavior is when we write as x approaches positive infinity, f of x approaches what? Okay, does it go up or down? Up is positive, down is negative. And so how does this help us? Well, when we write things in standard form, we can see the degree, leading coefficient, and the y-intercept easily. A degree tells us the number of slope changes on a graph. Okay, so like if I had, say, 1, 2, 3, right? So there's one going up, there's one going down, and then there's one more going up. So that degree is x to the third power. The leading coefficient tells us if the arrow on the right at the end of graph, which is on the right side, goes up or down. And the end behavior is the same thing. Okay, quick review. We're going to do exactly what we did at the end of yesterday's notes. I give you some equations. You have to match equations to the graphs and identify some important key information from the graphs. So, I would actually pause the video here and practice so that you can do it yourself. If you are having trouble with this part, I strongly suggest that you watch my video on 4.1a first. Okay, so let's take a look and just go over this briefly. There are 4 direction changes. 1, 2, 3, 4. So that's a degree of 4. 1, 2, 3, 4. And then 1, 2, 3, 4, 5. If they're opposite directions, it always has to be an odd number. Evens are always the same. Okay. Y-intercepts you guys can find quickly from the y-axis. And then leading coefficient, we know this one's positive, but I don't know what it is until I match it with the graph, knowing that the degree is 4, so it's x to the 4th power, and it's going to be a positive leading coefficient. And so that lines up with either g or h. H is negative, g is positive. So this one is g, this one is h. End behavior. As we go to the right for all of them, what happens to the graph? Well, this one goes up, so it's positive infinity. This one goes down, so it's negative infinity, and this one goes down. Okay. Hopefully that all makes sense and you got it all correct. For this next part, you will need a graphing calculator, so please have that ready to go. Let's do some quick, what's a degree, what's a leading coefficient? Based on the equation, what's the end behavior, and what's a y-intercept? Okay, so hopefully you figure out degree is this exponent. Leading coefficient is the number in front, which is an invisible 1. End behavior, since it's a positive one, I know that as x approaches positive infinity, it always goes to the right. F of x goes up. It's positive infinity. The y-intercept is always this last number, without a variable. Okay, so if there is a variable, then it's just, like say this one, then it's really plus 0, right, for your y-intercept. Okay, this next part, I didn't write this in, but on the test or quiz, there will be a place for you to fill in your x and y values. I'm going to go -2, -1, 0, 1, and 2. Now, if I plug in 0, hopefully you remember that 0 always goes with your y-intercept. If I plug in x equals 0, that gives me my y-intercept. So I can plug that in right away. That's here. Anything beyond that, though, by looking at the graph, we don't know. We don't know if it swoops up here and then goes up. We don't know if it goes through this as a highest point and then keeps going, right? Nothing we know, except that it's going to end up somewhere up here because of the leading coefficient being positive. So let's figure out how would you evaluate f of x if we know x equals 1. Well, hopefully you guys remember. It means we just plug in x, right? So we have positive 1 to the third power plus 3 times 1 squared plus parentheses 1 minus 1. Now this I want you guys to be able to do with a calculator and without a calculator. Guys, if you type this exactly into your calculator, you would get a number, right? And it would pop out, say, 4. Okay, so if you type this in, that's what you would get. I do also need you guys to know how to show your work on this one. And if I ask you to show your work, you need to be able to show me this. Or you have to show me that it's 3 times 1, because 1 squared is 1. But do you see how if I wrote this out, this makes it pretty clear what it is. 1 times 1 times 1 is 1, plus 3 times 1 times 1 is 3, plus 1 minus 1, that cancels out. So my final answer is 4. Okay. On your homework, you're going to be asked to evaluate, and you have to show 1, 2, 3, 4 lines, right? To show me, like, what do we multiply out, what are we adding, and what do we get? Well, beyond that, let's now pull out our graphing calculators. Let's say if you're not sure or you don't want to spend the time on it, then you really shouldn't be, because we have different technology that can help us save some time. So this page is where you want to be. Let me show you how to get there. If you want to graph, these 5 buttons at the top are where your graphing functions are. Notice there's a y equals, there's a window adjustment, you can zoom in and out, or you can trace your graph or graph. First things first, you have to hit y equals to know that that's where your graph is coming from. So we have to input our equation now. Okay, now where's x? X is next to alpha, and a power of 3. Squared is down here, but we want to go to the power of 3, so it's this little caret for a power. Okay, so x cubed plus 3x, and then I'm going to use squared here, or there's this button if you wanted to save time. Squared, right? Plus x minus 1. Check that that's what you have on your function. Now we're going to hit graph, but before we do that, we might want to make sure that our window is in the right place. So what happens sometimes, let me just change this randomly, is that some people see this on their graph because they put something in already, and like, do you see how you can't see both sides of the y-intercept? If that happens, you have 2 ways you can change things. You can go to window and manually type in from -10 to +10. SCL means count by 1, -10 to +10, right? And sometimes if the graph doesn't fit, you can change something here to make it fit. Say like a word problem where the y-intercept is 50, right? If I needed to make 50 fit, then I would put it here, but I don't want to count by 1s, maybe I'd count by 5s to make it clear. So I'm going to undo that. Okay. The other option is go to zoom. There are some window ranges that your graphing calculator remembers for you, and the one I always try is Z standard. So standard zoom. If you click on that, for the most part, all of my answers are between -10 and 10 for standard problems. Do you see how now everything shows? So the problem is I want to fill out a table, if you hit trace, you can sort of try to figure it out, but look at all those decimals. That's not very helpful. But there's this word here, table, which is what we have here, a table of values. Now, to get to the yellow numbers, or yellow words, I guess, you have to use the yellow button. It's like a shift key on the computer. Second, table, and now you have a table of values. Okay, so we can now go to -2, because that's what I want to graph. And I can fill in 1, 0, -1, 4, and 21. And then once we have this, we can graph what we have. So let's see. 1 goes to 4. 21 is like way up here. Okay. If I've at -1, there's a 0. And then -2 is at 1. Okay, but we do have a slight problem. You guys see how we have this graph that goes up? We have this part of our graph, but then we don't know what happens next, right? So you can sketch it here, or you can type in another number, and we want -3, -4. And so that tells me that, okay, I'm starting to come back down at this point. You got it? So let's do another one, just in case you need it. Number 7 is not written in standard form, so the first thing I need to do is rewrite it. -x to the 4th plus 3x squared plus 5. Y-intercept is 5. Degree is 4. Here's my leading coefficient, which is -1. End behavior. If the leading coefficient is negative, that means as x approaches positive infinity to the right, you are going to go down because the leading coefficient is negative. You see how these match? Okay, which is down. And at this point, you would do your table of values on the graph, but you have to change it. So go back to y equals, clear your equation, and it doesn't actually matter if you use the original equation or standard form. I actually would go back and use the original, because that means if you messed up writing or copying standard form, you'll still get the same graph or correct graph. 5 plus 3x squared minus x squared. Don't use negative. Negative is for the beginning. That's a minus. So let's graph it. That's a little weird because we think technically that there should be swoops, right? There should be 1, 2, 3, 4. So let's zoom out and see if maybe I only want to change the y's. So I'm going to change my y values to like 30. Okay, but still nothing changes. So here's something that you should know. Sometimes the changes in the middle are not clear if you're missing some x values here. Okay, so this looks, we know it's a 4th degree, but we're missing some of those terms because we're missing some x values. So let's grab our numbers for -2, -1, 0, 1, and 2. I'm going to go second table. Let's go -2 is 13, -1 is 7. We have 6, I think. No, that's a 5, sorry. 7 and 13. So we have 5, and we just know that it's going to go up like this. It's not perfect, it's okay, because I asked for a sketch, not exact values. Okay, give it a try. This is up to you guys now. Let me know in class if you have any questions.